3D printers today can be fairly plug and play. Unlike most other advanced manufacturing tools, they don't require a dedicated technician, and anyone can learn how to operate them in a few minutes. In this video, we'll compare the workflow and ease of use of the most common plastic 3D printing technologies, FDM, SLA, and SLS, starting with design and print preparation to machine setup, 3D printing, and all the way through post-processing. Before you start a print, you need a detailed 3D model of your part. CAD modeling is a skill that takes time to master, but 3D design software is much easier to use than it was a decade ago, and there are more and more custom tools for specific workflows that don't require hands-on design skills. 3D printers offer almost unlimited design freedom. You can print complex designs with lattices, overhangs, non-line-of-sight geometry, intricate or organic shapes, thin walls, and tiny details. That said, there are still some design constraints. FDM has slightly stricter rules, while SLA and SLS allow you to print the most complex designs. To prepare your print, use a print preparation or slicer software to specify print settings and slice the digital model into layers for printing. This print setup step can be as simple as clicking one-click print in Formlabs print preparation software Preform, or as complicated as manually choosing print settings and fine-tuning material settings. Low-cost printers of each technology typically require the user to do more work on the front end, and this can lead to part failures or inefficiencies in the print process. Professional FDM, SLA, and SLS 3D printers often have the option of setting up your models automatically, relying on thoroughly tested settings and material tuning. Most FDM 3D printers today are straightforward to set up, but some entry-level or DIY models require calibration and some experimentation with print settings. FDM printers can run prints unattended. Just make sure that there's enough filament on the spool to complete the print. With SLA 3D printers, lower-cost models require calibration and some experimentation with print settings for each material. During printing, you might need to refill the resin tank as well. Advanced SLA printers like the Form 4 series have automated resin dispensing, so there's no need to refill the tank manually. And they also come with validated print settings for each material, as well as a number of onboard sensors for smart monitoring during printing to ensure reliable results. SLS 3D printers require more space, infrastructure, and time to set up and have a steeper learning curve for operation and maintenance. But more accessible, easy-to-use printers like the Fuse series have made SLS printing straightforward enough that anyone can operate them independently with a short training. To 3D print, complete the pre-print checks, and then the printing process is automated. Post-processing is the final step of the workflow. Post-processing FDM 3D prints can be fast and easy under some conditions. For simple designs that don't require supports, you just need to remove the printed parts from the build platform. For more complex designs that are printed on supports, you can wash away soluble supports or remove hard supports by hand. FDM parts often exhibit clearly defined layer lines and support marks where the supports came in contact with the parts. Fixing these blemishes requires extensive sanding or smoothing, which can add significant time and overall hands-on labor, making it hard to achieve consistent results and reducing throughput. For SLA 3D printers, the foundational step of the post-processing workflow is to remove excess resin from the surface of the parts through an alcohol or ether wash. This washing step can be done manually or by using an automated washing solution that agitates the liquid for a preset amount of time. After cleaning, some SLA parts require post-curing to help them reach optimal material properties, which can also be automated using advanced post-curing solutions. Similarly to FDM, SLA parts that were printed on supports need these to be removed, but this can be fairly simple with advanced SLA 3D printers that use light touch supports, and the support marks are also easier to sand away. The basic steps for SLS post-processing include removing excess, unsintered powder from the parts and media blasting to fully clean parts and smooth surfaces. As both of these steps can be mostly automated and there's no need for support removal, SLS can be the least labor-intensive and most consistent 3D printing process, especially for larger volumes of parts. To sum up, FDM is the easiest 3D printing process for getting started and for simple designs, but it can be complex and time-consuming for more advanced applications. The SLA 3D printing workflow does require more post-processing steps than FDM, but most of them can be automated, and producing complex presentation-ready parts is easier than with FDM. SLS 3D printing has a steeper learning curve and requires more workflow steps and post-processing tools. But at high production volumes, it's actually the least labor-intensive of the three processes, which makes it ideal for industrial applications. If you're considering 3D printing, ease of use is not the only factor. Check out our other videos on print speed, cost, materials, and quality to learn more.